Okay, so we figured out, of course, after we drew our picture, we figured out that cosine pi over 8 was, of course, 2 plus the square root of 2 square root divided by 2. We also figured out that sine 17 pi over 8, well, we know 16 over 8 is 2, and that's 2 pi, as it's written. That just went around the circle once, like this, and then the extra 1/8 pi would put us back exactly here. So it was the same. The tangent of pi over 8, we figured out just from the definition of tangent, y over x. The last question here is, what is the tangent of minus 15 pi over 8? And where is minus 15 pi over 8? Well, first off, let's think about this. Where is minus 16 pi over 8? And then we'll backtrack a little bit. Minus 16 pi over 8 is simply minus 2 pi. Where is minus 2 pi? We start here. Here is minus 2 pi is just once around the circle. But we didn't actually go that far. We went minus 15 pi eighths. So what does that mean? It means we have to back up an eighth pi. So minus 16 pi eighths plus pi eighths equals minus 15 pi eighths. And we just did it. So here, minus 16 pi eighths is all the way around, plus 1/8 pi. It lands us right in the same place, so these are in fact the same. And as I said, by and large, especially if you're a scientist or an engineer really building stuff, you will be using advanced computers, way better than these calculators. You won't really be figuring out what these numerical values are in your head. However, it's really important to get this idea of how this is operating, I think. I think it will help you get good grades and have deeper understanding, which I think everybody really wants. Okay, let me see if there's anything more I want to do with this. Why didn't I use the unit circle? Okay, so this is why. As I said before, this is not, it's not a hard number to look at. I mean, it's just not integers or a fraction. So what would happen if I did this with the unit circle? 1, 2, 3, 4. And this is perfectly fine too. There's no problem with this. If this is the unit circle, that means r is 1 by definition. That means, so we have that, we're given that the sine of this angle, and I'm not going to write the angle in, it's too small. The sine is this. We know that this is y divided by r, but we already know that r is 1. That means that y is this whole thing. So this is the square root of 2 minus the square root of 2 divided by 2. This is 1. That means that this is 1 minus the 1 squared minus the square root of 2 minus the square root of 2 over 2 squared square root. Big bloody mess. Would it come out the exact same? Sure. Would all the numbers come out the same? I just thought that dealing with it like this would be easier. These are matters of taste and choice, and you will get the correct answer no matter which of these versions that you use. Okay, I think that's enough of that problem. I want to go back to some of the trigonometric identities. And I'll find some reasonably ugly ones from your homework and show you how I think we should do it. Let's see, how about sine squared t minus 2 sine t? Squared t minus 2 sine t. What else do we have here? Plus 1 divided by sine t minus 1. And what they want us to do is simplify this through algebraic manipulation, primarily whenever we can using this. This is about the only good thing that we have right now, and the things that we can make from this, like cosine squared x equals 1 minus sine squared x, or sine squared x equals 1 minus cosine squared x. You know, there's some other things that go along with this that they're hoping you remember. Remember. In general, a squared minus b squared is a minus b times a plus b. 1 is the same as 1 squared, even though we don't write it like that. We can also write these in terms of this. Cosine squared x is equal to, this is a squared minus b squared. This is 1 minus sine x times 1 plus sine x. And I don't know that we'll need this. Similarly, sine squared x is 1 minus cosine x times 1 plus cosine x. Let's see what we have here. This is a quadratic. If it wasn't sine x, we could think about this like this. This looks like x squared minus 2x plus 1. Hopefully everybody recognizes that this is x minus 1 times x minus 1. And if it's been a while since you've done algebra, you might be wondering how I got this, but this, we backwards factored this, right? This, we figured that this looks like this, x plus p or x plus q. And p and q can be positive. In this case, it's a minus sign, but that doesn't matter. So when you FOIL this out, you get x squared plus px plus qx plus pq. Factoring away the x, we have x squared plus p plus qx plus pq. Why am I doing this? Have I gone mad? No. Here's what's up. So we are looking for two numbers, p and q. So p times q, in this case, this is p times q. P times q equals 1, and that's a weird looking q. And also, p plus q equals minus 2. Well, so p times q equals 1, assuming these aren't some weird fractions or whatever, the most natural numbers are, p and q can equal 1. But then 1 plus 1 equals positive 2. So it must be that p and q both equal negative 1. Negative 1 times negative 1 is positive 1. Negative 1 minus negative 1 is negative 2. And this comes out. It's going to become increasingly important to look at form and not worry so much whether it's sign or anything else. If you end up seeing the rather ridiculous statement that cat squared minus 2 cat plus 1, and you want to factor that, this is simply cat minus 1 squared. Now this seems silly, but it really is about form and just what's obeying these rules that we've been learning. So anyway, so we know then that this is in fact sine t minus 1 times sine t minus 1 divided by sine t minus 1. Cancel this out. This is sine t minus 1. And I think that this answer is simple enough. A really important question is, remember, if we divide by 0, if this is equal to 0, the universe will end as we know it. Not really, but we like to pretend. Important question, when is sine t minus 1 equal to 0? And we have a small commercial break coming up, and we'll get right back to it.